So for this problem, we have a truck initially traveling at 10 meters per second, starts accelerating at 0.5 meters per second squared. How long will it take the truck to travel 100 meters during this period of acceleration? So the first thing I want to do is write down what we're given in the problem. So it says the truck is initially traveling at 10 meters per second. So the initial velocity is going to be 10 meters per second. And then it says it starts accelerating at 0.5 meters per second squared. So we're also given the acceleration. And then for the second part, it says, how long will it take the truck to travel 100 meters during this period of acceleration? So we could assume that the initial position is going to be 0. So di is going to be 0. And it's going to travel 100 meters. So the final position, df, is going to be 100. So let's write that in the givens. And it's saying how long will it take the truck to travel 100 meters during this period of acceleration. So we want to know the time of travel here. So we're trying to find t. So looking at the equations here, we want to find an equation that has all the given variables and then the variable t that we're trying to find. So if we look here, this first equation with df, that has all the variables we need, and we could find t using that. But we'd have to use the quadratic formula because we have a t and we have a t squared in here. So that would be kind of time consuming. So what we can actually do is we can use two equations to solve for t. So this Vf is equal to Vi plus At here. We know Vi, we know A, but we don't know Vf and T. But we could find it if we could find another equation to solve for Vf, we could solve for T then. Okay, so we know we can use this equation here, but we need to find another equation to solve for Vf first. So now if we look at this equation right here, we know Vi, we know A, we know df, and we know di. So we can plug in what we're given here, solve for Vf, and then plug it back into the equation Vf is equal to Vi plus At. So we solve for Vf, and then plug in the second equation, and then solve for T. So it's not quite as straightforward as the first method using the quadratic formula, but it is quicker. So let's use the method using two equations here. So again, let's start with the Vf squared equation. So we know Vi, we know A, we know df, and we know di. So we can plug in those variables and then solve for df. And we know di is equal to 0, so we can just cross that off. So we can just rearrange algebraically and then solve for Vf. So all I have to do is just take the square root of both sides and we get Vf. So now we can plug in variables and then solve for VF. So plugging in numbers, we get the value of 14.1 meters per second. But we can just check on the units to make sure they work out. So for the first quantity, we have meters per second, and that gets squared, so it's meters squared per second squared. And then the same thing happens for the second quantity here. So we have meters per second squared, and that gets multiplied by meters. So we have meters squared per second squared. But that whole thing gets square rooted. So we have the square root of meters squared per second squared. And if that gets square rooted, we're just left with meters per second, which is the correct units of velocity. So now we have our final velocity. So now we can use the second equation to solve for the time t. So now we can just rearrange and solve for t. So we solve for t, and now we're plugging the values. So if I put this in a calculator, I'm going to get 8.2 seconds. But again, let's just double check on the units to make sure they work out. So the units in the numerator are going to be meters per second. And then the units in the denominator are going to be meters per second squared. So if I cancel things out here, meters cancel with the meters, and then the per second in the numerator is going to cancel with one of the seconds in the denominator here. So I'm just going to be left with 1 over seconds. So if I have 1 divided by 1 over seconds, that's going to be equivalent to just seconds in the numerator. So I do get the units of seconds, which makes sense because I'm solving for time. So my final answer is going to be 8.2 seconds. So that's going to be the time of travel.